Welcome to Unacademy Computer Science. This is GATE Umamaheshwar Rao. Unacademy is conducting Major League Compact Guaranteed Scholarship Test in Mechanical Engineering, Civil Engineering, Electrical Engineering, Electronics and Communication Engineering, Computer Science and Information Technology. Test will be conducted on June 26 at 11 a.m. June 26 at 11 a.m. GATE and ESE Mechanical and Chemical get 4 months free on your iconic subscription. Attention, Unacademy GATE and ESE aspirants, get iconic subscription at just an additional 555 rupees per month. Live classes by top educators, 8,000 plus printed and digital notes per branch, unlimited access to recorded content, priority in raise a hand and ask a doubt features. Subscribe now. Use the referral code KUR75. to get 10% off. Special class features, interactive live classes, polls for the learners, raise a hand option, never miss a class, lecture notes, anytime, anywhere. You can attend live classes or participate in the live chat anytime, anywhere. Unacademy is conducting daily scholarship test. Grab this opportunity to win scholarship daily. Community feature for Android that facilitates an educator and learner connect even outside the classroom. Unacademy presents practice for GATE and ESE with Unacademy PYQs. Enroll now. Take 10-year subject-wise tests. Test your level of preparation. Get an All India rank. Unacademy is announcing new batches. Droppers batch for GATE 2023 and ESE 2023. Use code KUR75. Unacademy is announcing droppers batch for GATE and ESE 2024. Use code KUR75. Benefits of 1:1 live mentorship with your Unacademy GATE and ESE iconic subscription. One free 30-minute mentor introductory session. Scheduled session as per your convenience. Exam and preparation guidance. Progress report available to mentor for tracking learner activity. Unacademy is congratulating GATE 2022 top 6 rankers. Unacademy learners have cracked it. Unacademy is congratulating ESE 2021 mechanical top rankers. Features of Unacademy subscriptions: top educators, doubt clearing sessions, study notes, test series for both plus as well as iconic subscribers. Additionally, for iconic subscribers, physical notes is available. 1:1 live mentorship program, strategy and study program, live audio interactions during open house. Either for plus subscription or iconic subscription, use code KUR75. Use code KUR75. Today we would like to discuss functions. What is a function? A function is a unique correspondence between two non-empty sets. A function is unique correspondence between two non-empty sets. A unique correspondence between two non-empty sets is called a function. This is also known as mapping. A function f from A to B is a rule which assigns every element of A a unique element of B. A function f from A to B is a rule which assigns every element of A has a unique element of B. That is called f is a mapping. F is a mapping from A to B. F is a mapping from A to B. For example, this is A, this is B. A contains elements A, B, C. B contains elements 1, 2, 3. A maps with 1. B maps with 2. C maps with 3. A maps with 1, B maps with 2, C maps with 3. It is a function. It is a function. This is A. This is B. A contains elements A, B, C. B contains elements 1, 2, 3, 4. 1, 2, 3, 4. Now A maps with 1. B maps with 1. C maps with 2. Now every element of A is used, therefore it is also a function. Every element of A is used, therefore it is a function. This function is known as into function. It is known as into function. Next, For example, A, B. A contains elements 1, 2. B contains elements A, B, C. Now, 1 maps with A. 1 also maps with B. Then 2 maps with C. It is not a function. It is not a function. It is not a function. Understood? Next one. For example, A contains elements 1, 2, 3. B contains elements A, B. Suppose 1 maps with A, 2 maps with B, but 3 is not mapping with any element, then it is not a function. It is not a function. Understood? So, next one. For example, this is A, this is B, F mapping from A to B, 1, 2, 3, AB, 1 maps with A, 2 maps with A, 3 maps with B. It is a function. Every element of A is used. For every element of B, there is a pre-image in A. Therefore, it is a function. On to function. Okay, na? Now, try to write F inverse. Observe here. This is B. This is A. B contains AB. A contains 1, 2, 3. Now, A. 1 maps with A, so A maps with 1. 2 maps with A, therefore A maps with 2. B, 3 maps with B, therefore B maps with 3. This is called F inverse. Is it a function? No, F inverse is not a function. Because A maps with 1 as well as A maps with 2. That's why F inverse is not a function. Understood? F is a function, but F inverse is not a function. Next example. A, B. A contains 1, 2, 3. B contains A, B, C, D. Now, mapping. 1 maps with A. 2 maps with C. 3 maps with B. Now, D is pre-element. Now, different elements in A have different images in B. That's why f is 1 1 function. So now write f inverse this is B, this is A. B contains A, B, C, D. A contains 1, 2, 3. Now A maps with 1, 2 maps with C, therefore C maps with 2. 3 maps with B, therefore B maps with 3. D is free. Therefore, there is a free element in domain. That's why it is not a function. It is not a function. Now, A, B, A contains 1, 2, 3. B contains A, B, C. A contains 1, 2, 3. B contains A, B, C. 1 maps with A. 2 maps with C. 3 maps with B. F. F is function from A to B. Now here different elements in A have different images in B. For every element in B has a pre-image in A. That's why F is 1, 1 and onto. Now write F inverse. A maps with 1, B maps with 3, C maps with 2. That is F inverse. Now, different elements in B has different images in A. For every element in A has a pre-image in B. Therefore, F inverse is 1, 1 and onto. See, whenever F is 1, 1 and onto, then only F inverse exists. Whenever F is 1, 1 and onto, then only F inverse exists. If F is 1, 1 and onto, F inverse is 1, 1 and onto. If F is bisective, F inverse is also bisective. So, F inverse is a function if and only if F is, F inverse is a function if and only if F is 1, 1 and onto. F is 1, 1 and onto. Now, see here, A, B. For example, X belongs to A. X maps with an element in B. That element is nothing but Y. Y is nothing but f of x if f is the function. Suppose if g is the function, y is nothing but g of x. So here f a to b is a function. Then A is called domain. B is called codomain. B is called codomain. F of x is image of x. X is pre-image of y. A is domain, B is codomain, f of x is image of x, x is pre-image of y. Observe here. Suppose this is A, this is B. Whatever elements in A are mapped by the elements of B, that is known as range. Function of A, that is function of A. So this is known as range. B is codomain, A is domain. Understood? So f of A is nothing but range. What is range? Set of all images. Set of all images is range. Now, for example, A, B. A contains 1, 2, 3. B contains A, B, C, D. Now, 1 maps with A, 3 maps with B, 2 maps with C. Now, f of A means f of A contains ABC. Understood? So here f of A contains ABC. B contains ABCD. So what is conclusion? F of A is subset of codomain B. F of A is subset of codomain B. Now, suppose if F of A is proper subset of B, then it is known as into function. Suppose F of A equal to B, that is known as onto function. So if F of A is proper subset of B, that is known as into function. If F of A equal to B, that is known as onto function. Now, definition, onto function. First, one function. One function. F mapping from A to B is 1 F mapping from A to B is 1 if x1 not equal to x2, then f of x1 not equal to f of x2. Different elements in A have different images in B. Different elements in A have different images in B. Different elements in A have different images in B. That is 1. Next one is onto function. Onto function. F mapping from A to B is onto if for every y in B, for every y belongs to B, there exist x belongs to A such that for every y belongs to B there exists x belongs to A such that f of x equal to y, f of x equal to y A, B. A contains elements 1, 2, 3. B contains elements A, B, C. For example, 1 maps with A, 2 maps with A, 3 maps with B, then it is not onto. It is not onto because we are not able to find pre-image for C. That's why it is not onto. For the element C belongs to B, there is no pre-image in A. Because for C, there is no pre-image. For C, there is no pre-image in A. For C, there is no pre-image in A. That's why it is not onto. Next one. Bisective function. Bisective function. One and onto. F inverse exists if and only if F is bisective. If F inverse exists if and only if F is bisective. F inverse exists if and only if F is bisective. F of x is 2x minus 3. Then find F inverse. If F of x is 2x minus 3, then find F inverse. Y equal to 2x minus 3. Y is in terms of x. Write x in terms of y. X is y plus 3 by 2. X is nothing but F inverse of y. F inverse of y equal to y plus 3 by 2. Therefore, F inverse of x is x plus 3 by 2. F inverse of y is y plus 3 by 2. Therefore, F inverse of x is x plus 3 by 2. Next one. If f of x is x plus 3 by x plus 4, then find F inverse of x. Given that y equal to x plus 3 by x plus 4, y into x plus 4 equal to x plus 3, yx plus 4y equal to x plus 3, yx minus x equal to 3 minus 4y. Take x common, x of y minus 1. X of y minus 1 equal to 3 minus 4y. Therefore, x is 3 minus 4y by y minus 1. X is nothing but F inverse of y. F inverse of y is 3 minus 4y by y minus 1. Therefore, F inverse of x is 3 minus 4y by y minus 1. F inverse of x is 3 minus 4x by, because F inverse y is 3 minus 4y by y minus 1, therefore F inverse x is 3 minus 4x by x minus 1, where x not equal to 1. Where x not equal to 1. Next one. If f of x is 5x plus 1 whole square, then F inverse of x is y is equal to 5x plus 1 whole square. Therefore, five x plus 1 whole square equal to y. 5x plus 1 equal to root y. 5x equal to root y minus 1. Therefore, x is root y minus 1 by 5. X is nothing but f inverse y. F inverse y is root y minus 1 by 5. Therefore, f inverse x is root x minus 1 by 5. Next one. F of xy equal to x plus y comma x minus y. Then f inverse of xy is f of xy is x plus y comma x minus y. Then f inverse of x comma y is f of xy is nothing but u comma v. U comma v is x plus y comma x minus y. Now u is x plus y, v is x minus y. U plus v is 2x. U plus v is 2x. X is u plus v by 2. Next, u minus v is 2y. Y is u minus v by 2. Therefore, x comma y is u plus v by 2 comma u minus v by 2. X comma y is f inverse of u comma v is u plus v by 2, u minus v by 2. That is f inverse of u comma v. Now we require f inverse of x comma y. Therefore f inverse of x comma y is x plus y by 2 comma x minus y by 2. Next problem. If f of x comma y is 2x plus y comma x minus 2y, then f inverse of x comma y is u comma v is 2x plus y comma x minus 2y. U is 2x plus y. V is x minus 2y. Do one thing. Two x plus y is u. Now 2x minus 4y is 2v. Now subtract. Two x cancel. Plus 4y plus y, 5y. U minus 2v. Y is u minus 2v by 5. Next, similarly, 2u equal to 4x plus 2y. Two u is 4x plus 2y. V is x minus 2y. 2u plus v equal to 5x. X equal to 2u plus v by 5. X equal to 2u plus v by 5. Y is equal to u minus 2v by 5. Therefore, function of x comma y equal to, what is x? 2u plus v by 5. What is y? U minus 2v by 5. X comma y is nothing but f inverse of u comma v. F inverse of u comma v is 2u plus v by 5, u minus 2v by 5. Therefore, F inverse of x comma y is 2x plus y by 5 x minus 2y by 5. That is F inverse of x comma y. Result. First result, F function from A to B is 1 1. Then cardinality of A less than or equal to cardinality of B. Cardinality of A less than or equal to cardinality of B. Result 2. If F is function from A to B is onto function, then cardinality of A greater than or equal to cardinality of B. If the function is onto, then cardinality of A is greater than or equal to cardinality of B. Suppose if F is 1 1, then cardinality of A must be less than or equal to cardinality of B. Third point, F function from A to B is bisective. Bisective if and only if cardinality of A is equal to cardinality of B. Now, fourth point, if cardinality of A is N and cardinality of B is M, then number of functions from set A to set B is m power n ways. If cardinality of A is n, cardinality of B is m, then the number of functions from set A to set B equal to m power n. M power n. Next, if cardinality of A is n, cardinality of B is n, m, then the number of 1 1 functions, the number of 1 1 functions from set A to set B is equal to MPN. MPN, the number of 1 functions from set A to set B, MPN. For example, cardinality of A is 2, cardinality of B is 20. A function is selected from all functions from A to B. What is the probability that it is 1 function? It is 1 function. Now, total number of functions from A to B is given by cardinality of B power cardinality of A, 20 square, so 400. Next, number of 1 functions from set A to set B, cardinality of B, P cardinality of A, that is nothing but 20P2. P2 is nothing but 20 factorial by 20 minus 2 factorial, that is 380. Yes, 20 into 19, 380. Therefore, the required probability is given by 380 by 400, that is 0.95. 0.95. Understood? That is nothing but 0.95. Understood? Thank you.